there's something else I want to get at right now, okay? Something else I want to touch on a little bit right here. And that is, here we go. Let me just write this out. Basically, I'm using this kind of like a whiteboard here. Okay. Astronomy. Astrology. Here we go. Here we go. Whoa. Okay. Where's my cam? There we go. Astronomy versus astrology. Okay. Here we go. Big brain question time. Which one of these things are you in a class for right now? Which one of these things is this class about? This class is about astronomy. We will talk about astrology a little bit, but it's not the same thing. These are not the same thing at all. One of these is a science, and one of them is not a science. Somebody's worried that I didn't know if they were kidding. Don't worry, I know you were kidding. It's okay. Which one of these is a science? Astronomy. Okay, astronomy is a science. So, astronomy is the science of space and everything in it. And astrology is not a science. But I can't just say that. We got to understand what that means. And people make the mistake of calling one the other all the time. For a little while, I know at least once, my mom told one of my family members that I was getting a degree in astrology. And so astrology, if you don't know, that's studying constellations and the stars and the moon and the sun in order to tell the future, to tell your horoscope, to tell you fortunes of your future, right? And so my mom was telling people, accidentally told it. She was getting it right almost all the time, but she told one person that I was doing this, and I actually got some calls from that family member asking about horoscopes stuff. And they were like super disappointed when I told them, like, I don't know any of that. I don't know how to tell the future from the stars. Mainly because you can't tell the future from the stars. But like all that zodiac stuff, that's astrology, okay? Like, for example, you guys know the zodiac, right? Like, give me some zodiac signs. You guys know the signs of the zodiac? Throw me one of them out there. Yeah, Virgo, Leo, Scorpio, Oh, someone's saying, what do you mean we can't tell the future from the stars? Why are we... Okay, so there's a difference between making a prediction based on observations of the stars and thinking that the constellations in the zodiac, like Scorpio and Virgo and all of that stuff, can tell you like who you should marry, for example. So I can't just say one is a science and one is not a science, right? One is a science and one is not a science. So let's talk about that. What makes astronomy a science and astrology not a science? There's a lot of things, and we're probably not going to finish this today, but we're going to get at least into it a little bit. The main thing is anything that's a science has to follow a certain method. Do any of you guys know what that method that scientists use is called? What's the method of science called? Yeah, it's the scientific method, right? It's that one with science in it. It's the scientific method, right? So let's talk about this. So basically, astronomy follows the scientific method and astrology doesn't in a few important ways. But to understand how astrology doesn't follow the scientific method, we need to understand the scientific method. So let's just go through these steps real quick right here. Let's go through these steps just real fast like. So, does anybody know what the first step of the scientific method is? What's the very first step? What's the first thing you gotta do? So somebody's saying hypothesis, but we're actually talking before you get to the hypothesis. Before the hypothesis. Observation. Observations. You got to know something about the world around you or about the universe around you before you can decide what you're even going to study, right? So the very first step is just observation. And while I'm writing this, can anybody tell me an example of an observation? What's a way that we can observe things? What's the thing we typically think of when we're talking about observations? Someone's saying the sky is blue. And you would know that by watching it, right? By looking at it. So one type of observation is to look at something, right? I'm looking at my face and I see that I should have shaved better. That's an observation about my face. I'm looking at my hair and I'm realizing the COVID situation is making my hair very, very long. That's an observation. My hair is very long. So I got a haircut before the COVID situation. I haven't had one since. That's an observation about my life. Now, check this out. An observation is not just looking at something, it's hearing something, smelling something. Any way you take data about the world is an observation. So taking a photograph of something, that's another observation, right? Making a map of Florida, that would be an observation of the shape of Florida, right? So let's give an example that'll help us understand the difference between astronomy and astrology. Let's say it was 2,000 years ago, okay? Let's say it's 2,000 years ago. We're all wearing togas or something. I'm not a historian. I don't know what people were wearing. I just imagine togas. And let's say we went out today, well, 2,000 years ago, on August 25th, and we made a map of all of the stars that night. That map of the stars would be an observation of the stars. Okay, that map would be an observation of the stars. Now, let's say, here we go, let's say we waited a few months. We would notice that the stars were different from our map. That's another observation. Wait a few more months, the stars are different from the last time we looked at them. That's another observation. So we've observed that stars change where they are in the sky from day to day to day. Okay, these are just observations. But let's say we wait 1 year and come back on the next August 25th and made a map of the stars on that day, 1 year after the first time we made a map. What we would find in that case was that that map was exactly identical to the map we made a year ago. Now we've got a lot of observations. Now we can move on to what you guys were mentioning before, hypothesis. What is a hypothesis? What's a hypothesis? Somebody's asking about what that map would be like on literally today, 2,000 years later on August 25th. I'll get to that in a second. Hold that thought. Let's stay in the ancient times for now. Yeah, so some people are saying like an educated guess. And while it's close to what it means, I don't really like to call it an educated guess because people focus a little bit too much on the guess part and not the educated part. And I think that's because of science fair projects where, I don't know how you guys did it when you did science fair projects, but when I did science fair projects, my hypothesis was always pretty much literally just a guess. And a hypothesis is not just a guess, right? A hypothesis is an idea of how, it's an idea of how something works based on your observations. It's an idea about the universe based on your observations. Okay? It's not exactly a prediction, but it's related to prediction. You'll see the difference in a second. So, what's a good hypothesis? And a hypothesis doesn't have to explain why something works. It just needs to say what you think. What do you think is going on here? So let me put it this way. Here's a good hypothesis for this. If I saw the stars in the same place on 2 August 25ths in a row, and I saw that they changed between that, but they came back to the same place the next August 25th, a good hypothesis I can make for that set of observations is the stars always come back to the same spot on August 25th. Okay? The stars always come back to the same spot on August 25th. Okay? Now notice I'm not trying to explain why the stars do that. I don't really have enough observations at this point to worry about why, right? I'm just saying, based on my observations, I think the stars come back to the same spot every August 25th. Stars always come back to the same spot every August 25th. Okay, now, that's a good hypothesis for this set of observations. It's not exactly a prediction, and that's because that hypothesis, in its current state, the way I said it, is not actually completely testable. There's one word in my hypothesis that makes it not testable, not provable. Because check this out. I'll say it one more again and try to identify which word is the problem word in this hypothesis. The stars always come back to the same spot on August 25th. What word gives us a problem with our testing? While you guys are guessing that, I'm going to restart the dot cam. Always, yes. Always is a problem. Always. If I'm saying that I think the stars always come back to the same spot every August 25th, why is always not testable? Well, how long would it take to prove that it always happens? How long would it take to prove always? Forever. Always never ends. Always never ends. So I can't actually test always. There's no way in science to prove. We don't like to use the word prove, right? We just gain confidence in our ideas. And a hypothesis is one I maybe don't have that much confidence on because I haven't been able to test it yet, okay? But what I can do is use a little bit of logic on my hypothesis. So use logic to break up my hypothesis into a prediction based on that hypothesis. So there's no way to ever prove that the stars always come back to the same spot every August 25th, even if that is true. But what I can do is get a little more confident that I'm right in my hypothesis with a prediction. So let's see if we can make a good prediction here. Let's see if we can figure out what a good prediction would be. If I think that the stars always come back to the same spot on August 25th, because I've seen it happen twice, what would be a good prediction I could make to be more convincing in my idea? If I was trying to convince someone that my idea was right, yeah, that's a good prediction. That's a good prediction. Some of you guys are getting it. Some of you guys are getting it. So a good prediction from that hypothesis is, if I think that the stars will always come back to the same spot every August 25th, then my prediction will be that if I come back 1 year from now on August 25th, those stars would be in the same spot. Because if I'm right that they always do that, then a good prediction is they'll do it next time, right? And that is testable. That prediction that the stars will come back to the same spot next August 25th is testable because, again, what can I do? I could come back next year and look, right? I can actually test that, okay? I can actually test that. So that's what I'm going to do. I'm going to come back next year and test it by looking at the stars. Let me focus this a little bit. There we go. Sorry, that was a little out of focus for a little bit. Now, at this point, this test could yield two different results. What could happen at this point when I come back next year? What could happen when I test this? Yeah, I could be wrong, or I could be right. Just because something happened twice doesn't mean it always happens. That's what I'm trying to figure out, right? So at this point, I'm either going to be wrong or I'm going to be right. If I'm wrong, I have to reject my prediction. And if I'm right, I can accept my prediction. And if this were a science fair project, you're basically done. You slap a conclusion on it, and you turn it in. You make up a bunch of dates to put into your journal to pretend you didn't do it all the night before, and then you don't do that. That's bad, but I did that. Anyway, is the science done? Is the scientific method done at this point for real research? No. Whether we are wrong or whether we are right, all we did is get another observation. Because here's the thing. Did we prove by seeing the stars come back to the same place on August 25th 3 times in a row that the stars always come back to the same spot on August 25th? Did we prove that because in this case, if we did come back on that third year and did that test, we would find they were in the same place. But that's not proof that it always happens. But what we just did, though, was we made the hypothesis stronger. Because now we saw it happen 3 times, that hypothesis is now more convincing than it was before. And if we had come out and had to reject our prediction, we probably wouldn't completely throw out the hypothesis. We'd have to figure out, okay, if it happened twice and then not on the next time, I need to tweak my hypothesis. Something about it is wrong. Maybe all of it's wrong, maybe some of it's wrong, and you'd have to kind of tweak it. And so what are you going to do? Well, let's say in this case we came back, they were in the same spot. That means my hypothesis is stronger. What would be my next prediction to make? What would be a good next prediction to make my hypothesis that the stars always come back to the same spot on August 25th stronger? Yeah, my next prediction would be, I'm not going to go crazy and start to try to figure out exactly what's going on here yet. If I want to make that hypothesis stronger, my next prediction was, okay, if it's happened 3 times, if I think it always happens, then my next prediction is, if I come back on a 4th year, they'll be in the same spot again. And if I do that, I would find that they were in the same spot again. And so my next prediction would be, okay, if I'm right, it'll happen a 5th time. And then it would be, okay, if I'm right, it'll happen a 6th time. And every time it comes up right, every time my prediction comes up right, what happens to my hypothesis? What happens to my hypothesis if it keeps making correct predictions? If you use your hypothesis to keep making correct predictions over and over again. Yeah, it's more and more convincing over time. It is literally impossible to ever prove it, but the more times it makes correct predictions, the more confident we are that we're correct about it. There is never a single thing that is ever 100% proved in science. Scientists know that. Scientists, if you're going to be a scientist, you got to be okay with the fact that it is never possible to test something forever, right? So, but we can be pretty confident about our ideas if they've produced a ton of correct predictions. However, here's the thing. Once something has made a ton of correct predictions, we don't call it a hypothesis anymore. So if we go through this over and over and over again, our hypothesis will eventually get strong enough that we can call it a model. Once I'm super confident in my idea based on lots of testing and lots of predictions that have tweaked my hypothesis and gotten it more and more correct over time, I'm probably not going to call it a hypothesis anymore, because a hypothesis is a not confident idea. A model is a much more confident idea, right? Now, let's say I did that 2,000 years ago, and I spent my life doing it, and then I came to you guys, all the other scientists. In this story, you guys are all the other scientists, and I told you about my model, about the stars. My model is the stars move throughout the year, but they come to the same spot every August 25th. Is the science over now that I've tested it for like 30 years? Is the science done? Somebody's asking, is a model the same as a theory? Not exactly. Hold that thought. So, no, the science isn't done, because if you guys are good scientists, when I tell you about this thing that I am super confident about because of all my testing, what do you got to do? Do you believe me? Do you just believe me in that situation? Yeah, you're going to have to test it, because you can't just believe another scientist. Scientists, you don't just trust other scientists. You gotta check up on them. You check up on all the scientists. Scientists are constantly checking up on each other, right? There's a whole peer review process where other scientists check your work to make sure it makes sense. Because you don't know me. I could be a crackhead. I could be a crackhead that I just like popped out of my crack hole. Woo! And I'm like, oh, the stars always come back to the same spot every August 25th, guys. I saw it. I saw it. You don't know, just because, like, if you read my paper, you wouldn't know, that was the crackhead in the crack hole, right? So you gotta check it out. Is this a crackpot model, or is this model make sense? And what you guys are gonna do is you're gonna test it in ways that I never thought of before. I was doing all my testing where I lived. So you might say, okay, well, maybe you'd test it where I live. You'd see if it made sense, right? But you'd probably also test it in other places. Is that how, because the stars don't look the same in other parts of the world, as we'll talk about later. You might be like, okay, if it's true where you live, is it true in South America? Let's check it out. Is it true on top of a mountain? Let's check it out. And so over time, we would probably have to tweak it as we see little things that might be off, right? Now, eventually, though, we're going to start realizing that this model's pretty good, right? Eventually, we might have to, again, tweak it a little bit, but after a while, all of its predictions are going to start coming out right. And we're going to be very, 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 very confident about that idea. Basically, as confident as we possibly can be. And at that point, do any of you guys know what we call this? At that point, we're going to call it a theory. Once we are as confident as we possibly can be about this idea of how the stars work, we're going to call it a theory. And some of you guys might have been thinking law. A law and a theory are basically at the same level of acceptance. They're slightly different situations. Usually a law is a simple statement of something that happens. Like, this is something that happened. This is the way something happens. And a theory is more of an explanation of why it happens. Based, again, both of them are totally based on the observations, though. So theories and laws, those are at the same level of acceptance. This is basically the highest level of acceptance in science, okay? Which is unfortunate, because here's the thing. What does a theory, when you call something a theory in normal, everyday, regular human language, what do you mean when you say that's a theory? What do you mean when you say that? Sorry, we're going just a little bit long today. I'm almost done with this. We got like just a couple more minutes. Yeah. A hunch is an idea. Actually, somebody hit the nail on the head. What we normally mean in everyday speech when we say the word theory is really a hypothesis. It's an iffy idea. Theory, when you call something a theory for normal people, that's an iffy idea. But based on everything I said, is that what a theory means in science? No. What does a theory mean? When we call something a theory in science, what do we mean when we say that's a theory? How confident are we in that idea? Very confident. Literally as confident as we can possibly be. Remember I said you can never absolutely 100% prove something in science? The stuff that's as close as we can get is the stuff we're calling theories and laws. Okay? It's the stuff we're calling theories and laws. So anytime in this class and in other science class when they tell you about the theory of something or the something theory, know that that's not an iffy idea they're talking about. That is as close to proved as we can get on something. Here's a good example. Here's a very good example. The theory of gravity is an explanation for how things fall, right, on planets. And one part of the theory of gravity is that if I let go of this pin, what's going to happen to this pin? What's going to happen if I let go of pin? It's going to go down. That's a part of the theory of relativity. The theory of gravity, right? And we're very confident about how gravity works. We're very confident about the theory of relativity. We're very confident about the Big Bang Theory or the theory of evolution. We're not going to talk about that one. That's a biology thing. But so keep that in mind when we talk about this. Okay, so